Here's the problem. The problem is Justine is in hot pursuit of Alita. Alita is the third character in this thing. She's the criminal that we were basically chasing after. Justine and Lynette being the good girls, good guys. Yeah, the good people. Um, Justine is in hot pursuit of Alita. Alita climbs to the top of the roof and slides down the side of her the slides down the side of the roof on her frictionless skateboard. The roof has a vertical height of 1 meter and makes an angle of 30 degrees with the floor. Okay, let's do that. All right, you got yourself a roof. You got a girl on a skateboard, and there is no friction. Apparently, U equals 0 over there because she's standing on a frictionless skateboard, which is what she stole, by the way. Oh yeah, and it's up at a height h is 1 meter, and the angle is 30 degrees. All right, so here we go. Oh wait, no, that's not this. Let's go back to black. We got 30 degrees, and h equals 1 meter. Cool with that? All right. Now, after leaving the oh wait, Alita starts to rest, and her mass is 44 kilograms. Let's draw that in. Mass equals 44 kg. This one. Alita starts to rest, mass 44 kilograms. After leaving the slope part of the roof, she pulls the board out from underneath her and continues to slide on the floor. But the floor is not frictionless. In fact, the floor's coefficient of friction is mu equals 0.20. Okay. So then the girl comes over here, and she's sliding over here. I don't know why her dress turned into a skirt, but she's sliding over here, and mu is not equal to 0. Mu equals 0.20. Cool? So there's friction happening in between here. Here's my question for you. What is Alita's speed at point B? Solve this without using any kinematics formulas. Okay, so I forgot to label what point A and B is, so let's just make it up. This is point A, this will be point B. Sound good? What's her speed right there when she hits the bottom of the roof? How much work is done on the floor by Alita as she slows down and eventually comes to rest? So she's going to basically be traveling all the way over here to point C. She's going to slow down, right? Because of friction, it's going to slow her down. What happens when you slide something across the floor? Well, eventually it stops and slows down, right? Well, it slows down and then it stops. So that's kind of what's going on. So how much work is done by friction over here? Hint, hint. Force equals, or work equals force times distance. Oops, I just gave you the answer. Or at least not the answer, but at least a big hint. Alright, how far along the floor does she slide before coming to rest? Work equals force times distance. Therefore, you get the D. Cool. Alright, how would you get answers to part B and C, or how would your answers to part B and C change if the floor's coefficient of friction were double the original? Yeah, I know, in all honesty, I really don't care much about the numbers. What I really want to know is what would happen in kind of a qualitative sense. Would the distance half? Would it, would you stop in a quarter of the amount of distance? That kind of stuff. Any questions about this one? Good? All right, cool.